Hello there, Mr. Sutton, bringing you this lesson on other angle relationships in circles. Specifically, we're going to figure out measures of angles inside and outside circles. Our first relationship we'll look at is angles formed by a tangent and a chord. So I call this the tangent-chord angle relationship. If a tangent, like this one right here, and a chord, like this one, AB, intersect on a circle, then each angle formed by that intersection is going to be half of the intercepted arc. So to put it another way, when you have a tangent and a chord intersecting, you basically get two inscribed angles. It's hard to see that they're inscribed angles because this is such a steep kind of drop-off from the circle, but they are inscribed angles. So for example, the measure of angle 1 is going to be half of arc AB, and measure of angle 2 is going to be half of arc ACB. And while we're here, one thing that a lot of people forget in this situation, yeah, both of these arcs add up to 360. For that reason, both of these angles are going to add up to 180 degrees. Another way to think about it is if you have a tangent line is basically an inscribed angle on the entire circle. So again, this is going to be 180 versus 360. Using what we've just learned, see if you can find the missing measures in this problem. So the ones we're interested in for this first example here, we want angle 1, and on this example over here, we're looking for the measure of arc KJL, or LJK. All right, let's see how you did. So for this first one, we know this is going to be just half of the intercepted arc. So 1 is going to be half of 130, so 65. And then over here, the intercepted arc we know is going to be twice whatever this angle is. So that's going to be 250 degrees. Let's turn our attention now to lines that are intersecting off of the circle. So the chord-chord relationship says if you have two chords intersecting inside a circle, like so, then the measure of each angle is going to be half the sum of the two intercepted arcs. So in other words, the measure of angle 1 is going to be 1/2 whatever AB and DC add up to. Same thing for this other angle, which is a vertical angle, so it's going to be exactly the same as 1. Now, if you have things intersecting outside the circle, that gives us the tangent-secant angle relationship. If you have secants or tangents intersecting outside the circle, like so, then the angle here is going to be half the difference of the two intersected arcs. So measure of angle 1 would be 1/2 of BC minus AC. Given what we've just discussed, pause the video and see if you can find the value of x. Alright, since this is inside the circle, that means we have to take half the sum of the two intersected arcs here. So x is going to equal 1/2 of whatever 130 and 156 add up to. So that's going to be half of 286, which is going to be 143. This next one is a little less straightforward. Pause the video and see if you can puzzle out the value of y here. Alright, so this is talking about chords that are intersecting inside a circle. So the relationship we're going to use is that the angle in here is again going to be half of the sum of the intersected arcs. So that'll help us set up an equation involving y. But before we do that, we need to get one of these angles that y is actually the intersected arc for. So that will be 180 minus 102, 78 degrees inside here. And now we can say that our angle, 78 degrees, is going to be half of y plus 95. A lot of ways you could do this. I'm just going to multiply both sides by 2. That'll be 156 on the left. And then subtracting 95, that is going to be 61 degrees. Here's a problem involving two secants. Pause the video and see if you can figure out A here. So the relationship here is that this angle is going to be half of the difference of these angles here. So we can say 30 equals 1/2 of A minus 44. Multiplying both sides by 2, we've got 60. And then adding 44 to both sides, A is going to equal 104. For your wrap-up, we have this lovely circle with all of these different angles in it and arcs. Your job is to find the measure of all the numbered angles. Pause the video, give it a shot, and let's see what we came up with. All right, so I'm going to start with 1 just because it's 1. This is one of those tangent chord inscribed angles. It's going to be half the intersected arc. The arc is going to be 120 plus 100. So half of that, half of 220, gives us 110 degrees for angle 1. Angle 2 is supplementary with angle 1. They form a linear pair. So we just have to do 180 minus 110 to get angle 2, which is 70 degrees. Or you could do half of 80 plus 60, half of 140 is also 70. All right, moving on to angle 3. This is one of those angles that intersects the two outer arcs here. So this is going to be half of 100 plus 60. Half of 160 is 80 degrees. And then angle 4 is supplementary with angle 3. So 180 minus 80 gives us 100 degrees. Last but not least, angle 5 is formed by a secant and a tangent. That means it's going to be half of the difference of the intersected arcs. So half of 120 minus 60. That'll be half of 60, which is 30 degrees. And so, my friends, we come full circle. This is the beginning of the end of this lesson and this unit on circles. Until next time, this is Mr. Sutton signing off.